In this video, I would like to tell about the ethanol fuel demand forecasting in Brazil using a LSTM Recurrent Natural Network approach. Then we are going to see the overview of our process. Ethanol is a biofuel widely consumed in Brazil which functions as a substitute for gasoline. Due to several fluctuations in the characteristics of the Brazilian vehicle fleet and the political economic conditions of the country, forecasting ethanol consumption has become a difficult task to perform. The main objective of our process is to predict the ethanol fuel and to implement the forecasting and deep learning models for predicting the ethanol and to enhance the overall performance for both the models. Ethanol fuel is cost effective compared to other biofuels, so ethanol fuel is the least expensive energy source since virtually every country has the capability to produce it. The aim of our process is to forecast the ethanol consumption in Brazil using an approach of a long short-term memory, recurrent natural networks, and autoregressive integrated moving average model, that is ARIMA. And under the ARIMA, we have to implement this ARIMAX model. So this is the overview of our process. Then we are moving on the flow of our process. So first we have to take the data set, that is the ethanol fuel. The data set was collected from the data set repository like UGI repository and so on. After that we have to take the input data from the data set. Then we are going to implement the pre-processing step. In this step we have to remove the unwanted data or unnecessary noise from the input data. In this step we have to handle the missing values, then label encoding, then drop unwanted columns. The purpose of handling missing value is to avoid the wrong prediction. Then we have to encode the labels. That means we have to convert the strings into numeric. Then we have to drop unwanted columns which is not required for our process. Then we have to implement the data splitting process. The data splitting is to have to split the data set into test and train. Then we have to implement the forecasting. Before forecasting, the data split into test and train. In train part, the most of the data are stored. In test part, smaller portion of the data will be stored. After that we have to implement the forecasting model. The forecasting model means in here we have to predict the forecasting means we have to use the forecasting model, the time series data sets. That's here we are using the ARIMA or SARIMAX models for predicting the ethanol fuel. After that we have to implement the classification algorithm. In this classification we are implementing long short-term memory neural network model, and by using the LSTM we have to find the root mean squared error. So this is the flow of our process. Okay, now we are going to see about the demo part. We are running our process in Spider IDE from Anaconda Navigator. Just we are running our process now. After running our process, I will explain about the output. Okay, here our process is still on running. Yeah, first we have to data selection. This is the sample data from our input data set. Then we have to implement the pre-processing step. This is the one of the pre-processing steps, that is the handling missing values. Here all columns attributes contains the zeros. Zeros means there is no missing values in particular attribute. Yeah, our process is successfully ran. Just I will explain our process. So this is the result for ARIMA model results. All ARIMA model results. Just it displays. Just it will summarize our ARIMA models. Then we have to implement the SARIMAX. Here SARIMAX means he displays the coefficient value and standard error value. So both forecasting models automatically find the coefficient and standard error value. After that, this is the visualization. Just we have to display the forecasting models from our target values. Finally, we have to implement the classification algorithm, that is long short term memory. So the classification algorithms result got the root mean square error value. So this is our output. That is our sample output. This is our output part. Thank you.